Okay, we're here with Luke, and we're going to be talking about two kinds of exponents, zero exponents and negative exponents. Ready to go?
Yeah.
Okay, so first let's review. There's a rule about dividing exponents that you probably know. Let's review what that rule is. So first let's look at a case of division. Remember, a fraction is like division. So we have here 8 to the 7th divided by 8 to the 4th. And we want to know what that means. You probably have your rule in mind, but before we just do the rule, let's remind ourselves why the rule is true. So let's write this out. So we'll put 7/8 on the top and 4/8 on the bottom. Does that make sense to you?
Yeah.
Okay, good. So then what we can do is, if you remember, like this 8 right here and this 8 right there, well, those, what's 8 divided by 8?
1.
1. So those can just kind of cancel out and it'll be the same thing because it's just multiplying by 1. And do you see anything else that can cancel out?
Yeah, 3 more 8s.
Yeah, 3 more 8s. Okay, very good. So then what's left?
3 8s on top.
Yep, 3 8s on top. And how would we write that as exponents?
8 to the 3rd.
8 to the 3rd power, right? Just like that. Okay, so now we can go ahead and write the same thing up here. So we know that 8 to the 7th divided by 8 to the 4th is 8 to the 3rd. And another way we can write that is by writing this, because this is our rule here. So it's what you do when you divide exponents is you subtract. So here we have 8 to the 7 minus 4, because this is 7 and 4 here, and you're dividing. And that ends up being 8 to the 3rd. So do you remember that rule that when dividing, subtract the exponents?
Yeah.
And remember, it has to be the same base, 8 and 8. If it were like 8 to the 7th or 5 to the 4th, this doesn't work at all.
Yeah.
Okay? All right. Now, let's figure out what this would mean for negative exponents. So I'm going to take this same type of problem, but I'm just going to flip it over. And instead, I'm having 8 to the 7th over 8 to the 4th. I'm going to have 8 to the 4th divided by 8 to the 7th. Okay?
Okay.
So now, if we just apply our rule down here, what would we say? That's 8 to the what minus what?
8 times 4, or sorry, 8 to the 4th, or 8 to the 4 minus 7?
Yeah, 8 to the 4 minus 7th power, right? And what is 4 minus 7?
Negative 3?
Yep, so that's going to be 8 to the negative 3. Okay, so like, that's kind of weird. That's a negative exponent. We don't quite know what it means. But let's do the same thing we did down here and just write them out. Okay, so we're going to write out all of our 8s. So we have 8 to the 4th, 4 of them up here, over 8 to the 7th. Make sense?
Yeah.
Okay. And then remember, we can cancel a bunch of those out, right? Just like we did before?
Yeah.
So what are you left with here? Can you describe it?
3 8s on the bottom.
3 8s on the bottom. So on the top, what do you think we have? What's the best way to say what we have on the top?
None left.
We have none left, but remember when we divide 8 by 8 to cancel it out, what is that? 8 divided by 8 is?
1.
So at the top, we actually have 1. And on the bottom, we have 8 to the 3rd power. Does that make sense to you?
Yeah.
Okay, so we know that this equals this. We also know that it equals this up here. So we can set those two things equal to each other. We can say 8 to the minus 3rd is the same thing as 1 over 8 to the 3rd. Does that logic follow for you?
Yeah.
Okay, good. So let's say, like, how would you describe then what a negative exponent means? Could you tell me what this negative exponent is doing here? Let me try a draft rule with you and see if it makes sense, okay?
Okay.
Well, this is a draft because we don't know if it's true yet. A negative exponent means move to the denominator. So 8 to the negative 3 means moving that down to the denominator, 1 over 8 to the 3rd. That's kind of what's happening here. Does that description make sense to you?
Yeah.
Okay. So maybe that's the rule, but let's try another example really quickly to see if we can get to a final rule. So I'm going to do 1 over 5 to the negative 2. Okay. So we know that 5 to the negative 2, just like 8 to the negative 3 is 1 over 8 to the 3rd, 5 to the negative 2 is like 1 over 5 to the 2nd power, right?
Yeah.
Okay, so I'm going to replace this denominator down here with 1 over 5 to the 2nd. Do you see that? Does that make sense? Okay, so now we have 1 divided by 1 over 5 squared. You're kind of dividing by this fraction that's down here. Make sense?
Yeah.
So let's write that out in our division language. So that's 1 divided by 1 over 5 squared. Does that make sense to you?
Yeah.
Okay, when you divide by a fraction, it's the same as multiplying by the what?
reciprocal?
Good, the reciprocal. So let's do that. So this is the same as 1 times, and then we're going to take the reciprocal of this right here, 5 squared over 1. Is all this making sense to you?
Yeah.
Okay, so then what's 1 times 5 squared over 1?
1 times 5 squared.
Which is just?
25.
25, but just in exponents with the 5 as a base. How would you just say it?
5 squared.
5 squared, right? Okay, so we went through a lot of steps here to say that this thing is over here is equal to this. So let's just write that. 1 over 5 to the negative 2 is equal to 5 to the 2 to the second power. Okay, so here we had 8 to the negative 3 and it moved it down to the denominator. When it was in the denominator, a negative exponent, what did it do?
It moved to it moved to the numerator.
To the numerator, because this is just like 5 squared over 1, right?
Yeah.
So let's see if this rule that I've written down here makes sense to you. A negative exponent means move from the numerator to the denominator or from the denominator to the numerator. Just kind of go the other direction. So if you're into the denominator, you go up to the numerator. And if you're in the numerator, you go down to the denominator. Does that make sense to you?
Yeah.
Did we kind of prove it all out here?
Mm-hmm.
Okay, good. Now let's use some of this same thinking to figure out what a zero exponent means, okay?
Okay.
Okay, so let's look at this example here. Here we have a cubed over a cubed, okay? Mm-hmm. Now what's that have to equal? What's anything divided by itself equal?
1.
1. So we know that has to equal 1. Okay. Now let's also write it out though. A cubed over a cubed equals a times a times a over a times a times a, right?
Yeah.
And what can we do with these a's?
You can cancel them out or cross them out.
Yeah, we can cancel them out. So then what does that leave us on the top and the bottom?
1.
1. When 1 divided by 1 is what?
1.
1. So here we proved again that it equals 1. Okay, so there's 2 ways. Now let's use our other method of what dividing with exponents is. We're going to go ahead and we're going to say that a cubed over a cubed equals a to the 3 minus 3. Does that make sense?
Yeah.
Because you're subtracting, because you're dividing the exponents. Well, what's 3 minus 3?
0.
0. So that's the same as a to the 0, right?
Yeah. So
we know that a to the 0 has to equal what?
1.
1, right? So we can write that. A to the 0 equals 1. Now, what if a equaled 10,000?
Then it would still be 1.
Right. What if a equaled negative 422.976?
It would be 1.
Right, okay. So any number raised to the power of 0 equals 1. That's our rule. And that's what a zero exponent is. Makes things so easy. Because what if you have this problem right here? What's that going to equal?
1.
1. What if you have this problem here? A quadratic equation all to the 0 power. What's that going to equal?
1.
You got it. Okay. So negative exponents means move from the numerator to the denominator or vice versa. And zero exponents, anything to the 0 power is 1. Make sense?
Yeah.
Very good.